Yeah, today, just a little bit about these so-called sequences and series. There's a couple of specific types of these that we want to talk about. But first of all, just kind of some general things here about sequences and series. Sequences first. By a sequence, all it's really meant is just a list. It's a list of numbers, or really can be just about anything, but of course we're specifically referencing numbers. And usually there's a pattern. 2, 4, 6, 8, 10, etc., etc., etc. Yeah, this is a sequence. It's just a list of numbers, and of course this is the pattern, is it's the even numbers. We could do 1, 4, 9, 16, 25. Any thoughts on what those numbers are? They're odds and evens, but they're specifically square numbers. Yeah, 1 squared, 2 squared, 3 squared. So there can be all sorts of patterns that that do happen to develop here. Now we will look at some of these also. Notice those are equally spaced there by 4. So we'll take a look at more of those. So they can have various types of relationships amongst them. Now in general, a sequence, what we say, the terms are a sub. You have a and then a sub number there, a sub 1, a sub 2, a sub 3, a sub 4, so forth and so on. And then the nth term is the general term out there. We would call it a sub n for the general number of term that we're talking about. So we'll use that notation a little bit here. A sub 1 for the first term, a sub 2, so forth, okay? Keep that in mind. Now we can also use a sequence generator, you might call it. For example, the first sequence I have up there, we could call that a sub n equals 2n. Couldn't we? Wouldn't that generate the first sequence that I have up here? Because what I mean by that, a sub n equals 2n. So the nth term is whatever term it is times 2. So the first term is 2 times 1, right? And the second term would be 2 times 2, and the third term would be 2 times 3. You with me there? So that generates the first sequence. So that's another way that we'll see sequences. So what would a sub n be for the second one? A sub n would equal, if those are the squares, wouldn't it be n squared? Yeah, 1 squared, 2 squared, 3 squared would generate that sequence right there. All right? Now, we'll talk about these others, some others as we go along, but let's also take a look at some of these other a sub n sequences. What about, here's what they'll do. They'll say write the first 5 terms. So let's do that a little bit here and see some other patterns here. What if we have a sub n equals 2 to the n times parentheses n minus 1? They can get quite complicated, but this is about as complicated as we'll go. What do we get there? Well, my thought is just, well, let's just go one by one. If we've got a sub 1, that just means n is 1. So that'd be 2 to the 1 times 1 minus 1. Got 2 places to put the n there. What happens there? Well, 2 to the 1 is 2, but 1 minus 1 is 0. So that gives me 0. So the first term is 0. A sub 2, well, that would be 2 squared times 2 minus 1, right? Plugging in to be 2 there. It's kind of like just like a function, just plugging in 1 and 2. And let's see what happens. That would be 4 times 1, wouldn't it? So that's 4. A sub 3 be 2 to the third times 3 minus 1. 2 to the third is 8. 3 minus 1 is 2, so it'll be 16. A sub 4. Yeah, they'll usually want 5 terms, so let's go ahead and do that. What would that be? 16 times 3, 48. And then a sub 5, 2 to the fifth times 5 minus 1. That is 32 times 4, which is 128. Did I do those right? That sound okay? Let's see. Number 2, yeah, this is interesting thing happens on this one. Sort of like it. This one's 50n times negative 1 to the nth power. Does anybody know what's going to happen on that one? Well, it happens on this one, a sub 1. That's just n is 1. Do start, unless otherwise noted, with n is 1. So that would be 50 times 1, 50, times negative 1 to the 1. And what about negative 1 to the 1? It's negative 1, isn't it? That's 50 times negative 1, which is negative 50. So the first term is negative 50. What about the second term? Well, that would be 50 times 2. That would be 100 times negative 1 squared. But what about that? We square negative 1. That gives us a positive 1. So that's just going to be positive 100. Guess what happens on a sub 3? Well, a sub 3, we got 50 times 3, which is 150, times negative 1 to the third. But negative 1 to the third, we're back to negative 1. So that's 150 times negative 1, so that's back to negative number, negative 150. A sub 4, well, 50 times 4 is 200, but negative 1 to the fourth, and so negative 1 to the fourth power, we're back to a positive 1, aren't we? So that's 200, so we're positive 200. What's happening? Negative, positive, negative. They're alternating. So anytime you have a negative 1 to the nth power, something like that, the terms are going to alternate power, signs. A sub 5 then would be negative 250. Okay? So that's an interesting one there. One other one I may come across, you don't see this a whole lot, but they do show it up here. And that is this symbol with looks like a exclamation point. Seen that before? What that means, and talk about it more in some other classes, but it comes up more in like a probability or somewhere like that, statistics class. But anyway, just FYI, while we're at it, it's called Factorial. And there is a button on your calculator that does these, but here's what it means. A sub 1 is 1 factorial, which there's not much exciting about that. It's just 1. A sub 2 is 2 factorial, and let me explain what it means right there. What the factorial means is, I call it the countdown product. You start at this number and count down to 1, which this one's not real exciting either. It's just 2 times 1, which is 2. But when we get a sub 3, which would be 3 factorial, that's 3 times 2 times 1. So you start at that number and just count down to 1 and multiply all those together. So that's 6. A sub 4, 4 factorial, so that's 4, 3, 2, 1, which is 24. And then a sub 5 would be 5 factorial. So that's 5, 4, 3, 2, 1 multiplied together. Okay? 120? All right. So you may see that one somewhere along the way. Questions or concerns? All right. Let's talk about, where I got that one? Series. Next of all here. And basically what all is meant by series is it takes a sequence and adds a certain amount of the terms together. So a series is just basically it's the sum of a sequence. That's all a series is. It just takes the sequence and adds the terms together. So like on the evens, if I went up to 10, that's an example of a series. Just add the even numbers from 2 to 10. Just add that sequence up, 2 to 10, and that's a so-called series. And so on a series, usually you just get one number answer. The answer here for this series, or what this series sums to be, is, what is it at? 12 and 18 is 30? Okay, thank you. Yeah, so you're just going to come out on series, you're just going to come out with one number and get that answer. Now, there is some notation associated here with series. And the notation, well, you might have seen this symbol before. It's the Greek letter sigma, but that Greek letter typically means summation, or sum up some terms. So, but that's typically in mathematics the summation symbol. So you usually see that in mathematics. It means add up some terms. Now, let me just show you here how I can write this series in this summation notation. Well, it's the a sub n is 2n, right? So you put that here. Then you put what's called an index on that. And by index, what I mean is what the n is going to run to and from and to. So in this case, don't I run n from 1 to 5? Start with n equals 1 and run it to n equals 5. That's what this means. So this means this top and bottom stuff means start at n equals 1 and go to n equals 5. Okay? So that's called the index. Yes. Because sometimes this will change. The index could be I. Doesn't have to be n. So yes, usually you will see that written. Okay? So yeah, this right here means this right there. So I start with n equals 1, so that would be 2. N equals 2 then would be 4. N equals 3. So I get the same thing. Stop at n equals 5, so it would be 10. Okay? So that's going to be the same thing. All right. So let's try another one here. What does this series equal? Let's say I've got the summation n equals 1 to 4. Then I have 2 to the n plus 1. What does that equal? Well, just go term by term. In this case, again, I'm starting at n equals 1, so what's the first term? 2 to the 1 plus 1? 3. Okay. Second term, n equals 2, so that would be 2 squared plus 1. That would be 5. 4 plus 1. Third term, 2 to the third plus 1. 2 to the third is 8. 8 plus 1 is 9. And then the fourth term, the last term, 17. 2 to the fourth is 16. Yeah, and since this is now a series, that's the summation symbol that says add those all together. 3 plus 5, okay, that's 34, isn't it? Okay, so it's basically one step, taking it one step further, and that is add the terms together. Okay? All right, make a point here. A couple more points here. So I go the summation I equals 3 to 6 of 7i squared. That's what I was saying before. The I could be the index. Doesn't have to be necessarily n. You may see a J or a K. The index could be just about any letter. But those are the more common ones. Then the other point here is, where do I start? This one starts at 3. You don't have to start it always at 1. This one says start at I equals 3. So what's the first term here? It'd be 7 times 3 squared. Plugging in I to be 3, so the first term would be 63. 7 times 9. Then the second term would be plug in 4, because then we just go 3 to 6. So that's 7 times 16, which is, 7 times 16 is it 112? Okay. Then the third term would be 7 times 5 squared, 7 times 25, which is 175. And then 7 times 6 squared, 7 times 36. What do you got? 252. Okay. So that one again has 4 terms, but you start at 3. All right. So this is, what does all that add together? So we got it? 602? Is that okay? All right. Now, let me make another point here about this one. Well, first of all, it will be an important point later on, too, to know how many terms we have, maybe even before we start. Like on this one, I've got 4 terms, right? On the first one, I've got 4 terms. Well, that's good because I've got a 4 right there. However, you can't always go with that number as the number of terms because this one doesn't have 6 terms. And that was because I started with something other than 1. If it starts at 1, then this number is the number of terms, right? But if it starts at something else, you have to make adjustments. Now, the reason this one was only 4 terms was because if we went 1 to 6, we'd have 6, but we started at 3, so we left off the term 1 and 2, right? So that's why we got down to 4. But you can make those adjustments as we go, but just be aware. All right, now let's talk about that. This one. Let's say I go n equals 0 to 5, n squared minus 4n plus 2. How many terms does that one have? That one's going to have 6, isn't it? Because, yeah, you can actually start, your index can start at 0. And so, yeah, 1 to 5 would have 5, but I've got an extra term, don't I? So this one's going to have 6 terms. So I'm expecting 6 terms here. What are they? Well, the first term, plugging in to be 0. 0 squared minus 4 times 0 plus 2. Hey, that's just 2, isn't it? First term's 2. 1 squared minus 4 times 1 plus 2 would be the second term. So that's 1 minus 4 plus 2. Is that negative 1? And, yeah, that's another point here. Terms can be negative. You can have negative value terms. That one turns out to be, I think it may be the only one, but because the next one, this third term, and do it down here, would be 2 squared minus 4 times 2 plus 2, right? It's also negative, isn't it? Huh? Did I do something wrong? 4, 6, yeah, that's negative 2 also. So got another negative term. Third one, 3 squared minus 4 times 3 plus 2. That's back to negative 1. Fourth one, n equals 4. 4 squared minus 4 times 4 plus 2. That one's back to 2. 16 minus 16 plus 2, right? Fifth one is 5 squared minus 4 times 5 plus 2. 25 minus 20 plus 2. That's 7. And then the last that's the last one. We only go to 5 there. Okay? All right. So what happens when we get adding those together? 11, 7? 7. Okay. All right. Questions or concerns about our little